Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your younger brothers and sisters, and to your friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies as part of your preparations to engineering life, then please don't forget to subscribe. Level 112, determine I sub x, I sub y, and the product of inertia Ixy for the rectangular plate with three equal circular holes. So here is the figure. So for Ix, we have Ix of rectangle with respect to the x-axis, and x-axis is the centroidal axis of the rectangle. So it is 400 times 200 cube over 12, then minus 3 times moment of inertia of circle with respect to the centroid is pi r to the fourth over 4, then plus area quantity plus area pi r square pi times 30 square barred y square, and barred y is 50 regardless of 50 negative or 50 positive. So Ix equals 400 times 200 cube over 12 minus 3 times quantity pi times 30 square over 4 for circle with respect to the centroidal axis plus area pi times 30 square distance 50 square. 50 or negative 50 quantity square, that's the same. So I sub x is equal to 243.6 times 10 to the 6 millimeters to the fourth. Then I sub y, this is also the centroidal axis of the rectangle. So it is 400 cube times 200 over 12, then minus 3 times pi 30 to the fourth over 4, area pi 30 square, then barred x square. Barred x is 100 for the three circles. Minus 3 times pi times 30 to the fourth over 4 plus pi 30 square times 100 square. Solving for Iy, I sub y is equal to 979.9 times 10 to the 6 millimeters to the fourth. Then finally, the product of inertia with respect to the xy axis. For the rectangle, it is 0 because both x and y axis are axis of symmetry. Then minus, supposedly, 3 times product of inertia of the circles. But since these two circles are symmetrically placed about the y-axis, so they will just cancel the effect. So we only have this part, which is minus quantity pi times 30 to the fourth over 4 plus area, minus product of inertia with respect to the centroid 0, then minus area pi 30 square over 2 pi 30 square, then barred x negative 100, barred y negative 50. So that is Ixy equals 0 for the rectangle minus just this one, because these two will be 0 symmetrical about the y-axis, so just this one. So minus product of inertia with respect to the centroid, which is 0, then plus area pi 30 square, barred x is negative 100, barred y is negative 50 mm. So negative of positive is negative. So Ixy equals negative 14.14 times 10 to the 6 millimeters to the fourth. Giing level 113, determine the product of inertia with respect to the xy axis and the centroidal product of inertia for the triangular area shown. So here is the given figure. So let's have for our solution horizontal strip. The length of the strip is right x minus left x. The distance of the centroid of the strip from the x-axis is denoted by y. So this point is at a comma h, then that is y, thickness is dy. This point, then this is h minus y, this point is at right x comma y, while this point is at left x comma y. And this point is at b comma 0, while that point is at left x comma y. So the centroid of the differential element, so Ixy equals integral of x, y, dA. Remember that x is the x-coordinate of the centroid, and in this case, it is the midpoint formula, 1/2 of quantity right x plus left x. So that's the centroid of the differential element, and that is quantity right x plus left x over 2. Y is just y, and dA is right x minus left x dy. So the length of the strip is right x, because this is right x, minus left x, then the thickness is dy. Simplifying, Ixy equals 1/2 quantity integral from 0 to h of right x squared minus left x squared times y dy. So let's derive right x and left x by defining the slope of this part. So m1 equals y minus 0, because this is at 0 over xl of minus 0, and it is equal to h minus 0 over a minus 0. So therefore left x is ay over h, and squaring left x, that is a square y square over h square. Similarly, we call the slope of this side as m2, and m2 is upper y minus 0 over right x minus b, and it is equal to h minus 0 over a minus b. Simplifying, xr minus b equals quantity a minus b times y over h. Transposing b to the right, xr equals b plus quantity a minus b y over h. Squaring, xr square equals b square plus twice the product 2b quantity a minus b times y over h plus square of the second term a minus b square y square over h square. Substitute into this formula here, Ixy equals 1/2 integral of from 0 to h of y, then b square plus 2b quantity a minus b close times y over h plus quantity a minus b square over h square y square, then minus a square y square over h square dy. Uh, Distributing y, so we have Ixy equals 1/2 integral from 0 to h of quantity b square y minus plus 2b quantity a minus b y square over h plus we expand. The first term is a square y square a square y square over h square, so this will vanish, the first term. The second term is negative 2ab y square over h square. Since there is y here, so it becomes negative 2ab y cube over h square. That's the middle term. The first term is out, and we remove also this. The last term is positive b square y square over h square times y. So it is positive b square y cube over h square. So I hope you can follow. That is only algebra. So integrating, Ixy equals 1/2 quantity b square y square over 2 plus 2b quantity a minus b y cube over 3h minus ab y to the fourth over 2h square, because it is 2ab over 4, so ab over 2. Then b square y to the fourth over 4h square from 0 to h. So before combining, we substitute upper and lower limits. Ixy equals 1/2 quantity b square h square over 2 plus 2b quantity a minus b h cube over 3h square, 3h rather, minus ab h to the fourth over 2h square plus b square h to the fourth over 4h square Then simplifying, combining like terms, we have 1 half b square h square here. Then let's simplify first. So ixy equals 1 half quantity b square h square over 2 plus 2b quantity a minus b h square over 3 minus ab h square over 2, then plus b square h square over 4. So 1 half, we have b square h square here, 1 half, then plus 2 thirds, 2b minus 2 thirds rather, minus 2b h square over 3 minus 2 thirds, 1 half minus 2 thirds plus 1 fourth, then it is in terms of b square h squared then divided by 2. For AB, we have 2 thirds AB h square, then minus 1 half AB h square. So combining and simplifying, we have b square h square over 24 plus AB h square over 12. Factoring out b square h square over 24 and writing the result first here. So we have b square h square over 24 times quantity 2a plus b. So that's the product of inertia with respect to the xy axis. Now, how about the centroidal product of inertia? So we use the transfer formula for product of inertia. So the location of the centroid from analytic geometry, the x-coordinate is simply 1/3 of the sum of the x-coordinates. So 1/3 of quantity a plus 0 plus b. So that would be a plus b over 3. Again, 1/3 of a plus 0 plus b is 1/3 of a plus b. While the y-coordinate is 1/3 of h plus 0 plus 0, so h over 3. That's y sub c. So ixy equals I barred xy plus area barred x barred y. And we already defined the barred x, which is quantity a plus b over 3, and barred y, which is equal to simply h over 3. And the area of the triangle is 1 half base b times height h. So b square h square over 12 over 24 times 2a plus b equals I barred xy plus 1 half of bh times a plus b over 3 times h over 3. Distributing b square h square over 20 over 12 over 24 rather plus ab h square over 12 from this original results here equals I barred xy, and if we simplify this, this is ab h square over 18 plus b square h square over 18. So combining like terms, 1 over 24 b square h square minus 1 over 18 b square h square. Then we have 1 over 12 ab h square minus 1 over 18 ab h square. We write 112 minus 1 over 18 first because it is positive. So it is equal to ab h square over 36, then minus b square h square over 72. Factoring out b square h square over 72, so I barred xy is equal to b square h square over 72 times 2a minus b. So that's it, and I hope that you were able to follow the solution. It's only algebra that prolongs the solution here. Level 114, determine the product of inertia for the area with respect to the x and y axis. So here is the given figure. Let's have a horizontal strip again for our solution. The right x is 8 inches, the left x is just x, so therefore the length of the strip is 8 minus x as shown here. The thickness is dy, the distance of the strip from the x-axis is y, and therefore the thickness dy. The differential area is area of this rectangular strip 8 minus x times dy. So that's the centroid. The centroid is the average of the right x and the left x. So therefore that distance of the centroid from the y-axis is 8 plus x over 2, right x plus left x divided by 2. So ixy equals integral of xy dA from 0 to 2 because the variable of integration is y. So we have 0 to 2. And x is not x, it is the x coordinate of the centroid, which is quantity 8 plus x over 2. The y is y, just y here, and the differential area 8 minus x dy. So ixy equals integral 0 to 2 of 8 plus x over 2 times y, then 8 minus x dy. Simplifying, ixy equals 1 half integral of from 0 to 2 of 64 minus x squared times y dy. Now, if we square this x here, x squared, then we should square this one. So x squared therefore is y to the 6. So we replace x squared by y to the 6. Ixy equals 1 half integral from 0 to 2 of quantity 64 minus y to the 6 times y dy. So Ixy equals 1 half integral from 0 to 2 quantity 64y minus y to the 7 dy. Integrating Ixy equals 1 half quantity 32y squared minus y to the 8 over 8 from 0 to 2. So Ixy equals 1 half quantity 32 times 2 square minus 2 to the 8 over 8 minus lower limit 0. Simplifying, Ixy equals 48 inches to the fourth. So that's it for this problem. Level 115, determined by direct integration the product of inertia of the given area with respect to the x and y axis. Here is the given figure. And for our solution, let's have vertical strip this time. The height of the strip is y, the thickness is dx. So the variable of integration is x, limits would be from 0 to a. And the location of the centroid is here. So the distance of the centroid from the y-axis is just x. And the distance of the centroid from the x-axis is y over 2. So Ixy is integral 0 to a of xy dA. Remember that this is not automatically the direct formula. So x in the figure is the x coordinate of the centroid, which is just x, while y is half of y because this distance is y over 2. And y here is the y coordinate of the centroid of the strip. And differential area is area of the strip, which is y dx. So Ixy equals x, integral of x from 0 to a of x times y over 2 times y dx. The area's differential area is y dx. And y is the y coordinate of the centroid, this distance, which is y over 2. So Ixy equals 1 half integral of x y squared from 0 to a dx. So the variable of integration is x, so we must express y in terms of x. So y is kx to the 1 half, and at this point here y is b, x is a, so b equals k a to the 1 half. That means the constant k is b over a to the 1 half. The equation of the curve therefore is y equals b over a to the 1 half times x to the 1 half. And since this is y square, squaring both sides, y square is b square over a times x. Substitute, Ixy equals 1 half integral from 0 to a of x quantity b square over ax dx. So Ixy equals b square over 2a, then quantity x cubed over 3 because we have integral of x squared dx from 0 to a. So Ixy equals b square over 6a times quantity a cubed minus 0 cubed, which is just 0. So finally, Ixy equals a square b square over 6.